which is going to show us on how to calculate the inverse of any 2 by 2 matrix. So how do you know if a matrix has an inverse and what that inverse is? So let's say we are given in a matrix A, which is A, B, C, D, and you're supposed to get the inverse of that matrix. So this is the formula that you use in calculating the inverse of any 2 by 2 matrix. So A inverse is given by 1 over the determinant into brackets D minus B minus C and A. So how do we get these values here? When you look at these values, you realize that in this diagonal where we have got AD, this diagonal AD, look at this one, DA. So those values have changed the position. This one is AD. So when you're getting the inverse, it will be DA, this diagonal. What about for this diagonal, BC? This diagonal, this one is BC, this one is BC. So when you come to this part of the inverse, this one will be negative B, negative C. So what has happened here is that the sign has changed. This one was BC, this one is negative B, negative C. And this one, the positions have changed. This one is AD and this one is DA. So this is the formula for getting the inverse of any 2 by 2 matrix. Then you remember, how do you get the determinant of any matrix like this matrix A? We get the determinant by AD minus BC, where AD is the multiplication of this A times D and this one is B times C. So that is what gives us the determinant. So we proceed. Now example, determine whether the matrix has an inverse. If the inverse exists, then find it. So we are given matrix M. We are supposed to find the inverse of this matrix, and we are supposed to calculate that inverse. Actually, we determine whether it has an inverse, and if it has an inverse, then we calculate that inverse. So to begin with, step number 1 is getting the determinant of this matrix M. So getting the determinant, we are going to remember our formula for getting the determinant given by AD. In this case, our AD is negative 2 times negative 4, then minus BC. BC is 2 times 5. So when you do that computation, you get this one is negative 8, negative 10, and this one is positive 8, minus 10, which will give us negative 2. So therefore, this matrix has determinant of negative 2, and therefore the inverse exists. So it has got an inverse. So the other thing that you are required to do in that question is to find that inverse. Now that we have established that the inverse exists, so the next step is to find that inverse. So for us to find the inverse, we have to rewrite this on step number 2. Rewrite this one in this form. Remember how we interchange these values. So we write in that form. So we noted in our previous slide how to change these values. For this diagonal, the values will change the signs. This one is 2, 5. So we expect the values here, when you write, we're getting the inverse to be negative 2, negative 5. And that is what we have, negative 2, negative 5. So these values for this diagonal will change the positions. These ones will change the positions. So we will have, this one is negative 2, negative 4. So we'll have negative 4, negative 2. These are negative 4, negative 2. So those values for that diagonal will change the positions. So that is how we write this matrix in this form, so that we can proceed and get the inverse. So after writing that, step number 3, use the equation to find the inverse. We said the inverse of any matrix is given by 1 over the determinant. We got our determinant for this matrix as negative 2 into brackets, the values that we got after interchanging, and this is what you got. So this one means that everything that is inside the bracket has to be multiplied by 1 over negative 2. Everything that is inside the bracket there. So 1 over negative 2 times negative 4, 1 over negative 2 times negative 2, 1 over negative 2 times negative 5, 1 over negative 2 times negative 2. And when you do that multiplication, this is what you're supposed to get. So this is now the inverse of matrix M. So example 2, determine whether the matrix has an inverse. If the inverse exists, then find it. So we start with the first thing is to get the determinant of that matrix. So determinant is given by AD minus BC, where AD is given by 2 times 3, then minus, this one is BC, BC is 4 times 1, and this is what you get, 6 minus 4, which is 2. So the determinant is 2. So that is the first step, get the determinant. And because you've got 2, then the inverse exists, we can proceed and get the inverse. So inverse is given by 1 over the determinant. Then remember how we interchange these values? We said for this diagonal, this is 2, 3. Those ones will change the position. So if this one is 2, 3, in this part, this one will be 3, 2. The positions will change. Then for this diagonal, this is 4, 1. So the signs will change. So this one will be -4 and -1. Then you multiply everything that is inside here by a half. So a half times 3, which is 1.5. A half times -4, which is -2. A half times -1, which is -0.5. A half times 2, which is 1. So the inverse of that matrix is therefore given, and we are through with that. So thank you so much. We are through with this part on calculating the inverses. So very important things to highlight when you're getting the inverse. Look at the steps that you have followed. When you're getting the inverse, don't forget the first step is to calculate the determinant. The second part is to interchange the values. And the third step is now getting the inverse. So those are very important things for you to remember as you are getting the inverse. Also, it is very important for you to remember this formula for getting the inverse of any 2 by 2 matrix. Remember this formula, don't forget it, it is very important. So thank you so much for watching the video. We are going to prepare more videos on matrices. So thank you so much.